Alrighty, good morning, KAP, Tuesday the 26th. Our warm-up is related to the video lesson that you should have watched yesterday, talking about when we use each type pi. So we had 3 different types that they talked about yesterday. Let's hear some feedback on each of the different ones. What is it? Oh, Lord. All right. So we talked about 3 different types of pi: 3.14, 22 over 7, and then just 3. Let's share, when was each one? Don't tell me all 3, just pick one. When is it a good time to use that, Michaela? Okay, whenever the diameter or the radius is a multiple of 7. That way you can cancel out stuff. We did one problem yesterday where we were able to cancel it out. Again, you don't have to, but it really helps, like, get away from decimals and stuff like that. I'll take that. It says 21 over 7 on your worksheet. You need to fix it to 22 over 7. In the recording, it said 22 over 7. I don't know what happened when we printed this piece of paper. It changed the 1 to a, or the 2 to a 1. It should say 22. Because if it's 21 over 7, that would simplify down to 3, which is not pi. Okay? June. When estimating, we use 3. Anything else to add to that? No. Did they talk about multiple choice questions at all in there? And which one's the best one to use for multiple choice questions? June. Yeah. Okay. Estimating for multiple choice questions, unless there's answers that are really close, I would always use 3 for multiple choice. Because it can either, like, it's going to be close, okay? But if I use 3, is my answer going to be above what I calculate, or is it going to be below what I calculate? Above, because I'm rounding down. I'm taking off that 0.14, so the answer would need that extra little bit. If 2 answers were really close, I would use 3 to eliminate 2 answer choices, and then maybe actually 2 times 3.14. Okay, but if all of them are like really different answers, I'll be like, nah, I'm on to 3. Okay, it's okay to be lazy. It's a strategy.
I know it's the best.
All right, and 3.14, Carolyn.
Unless otherwise stated, it's used.
Yeah, this is like our default setting. Or unless other specified. Okay, great. Are we good about that? Okay. It's very useful to know these 3 forms because you work less. Again, when you use 22 over 7, you can avoid decimals. When you use 3, you can avoid decimals and fractions. And then sometimes life is just hard to do. Okay. So on number 3, it says to estimate the circumference of the circle below. Keyword. Estimate. So we're going to use 3. Great. So the given dimension that 300 inches is my radius. Inches. That's those inches. Therefore, my diameter is going to be 600. It doesn't matter which formula I use. No. But I tend to use the one that's given. So this is my radius. So what's the formula using the radius? 2 pi r. Substitute in. C is equal to 2 times 3 times 300. And then math. What does that give me? 1,000 inches. Is it 1,000? Oh, sorry. Haha. Gotcha. 1,800 inches. Y'all good with that?
Yeah.
All right. How come? What? 300 inches is the radius, so it's going to be 600 inches across. Is that drawn to scale? No. All right, here we go. Were there any questions on last night's homework? I'm not going to this. All right. What we are going to do is we're going to watch a YouTube video. I watch it twice every single year. I will record the first time through for those of y'all at home. But then if you want to watch it again, you can. I always play it twice for my classes because it's pretty mind-blowing. It's low quality, but high. Okay, here we go. Oh, one second.
where it gives you the area of a circle. But where does pi r squared come from? First, we'll draw a circle and fill in its area. Next, we will divide it into large equal parts and arrange them in a rectangular formation. As you can see, it barely resembles a rectangle. So next, we will divide the circle into small pieces, and we will arrange them in the same manner. You can see that it appears more like a rectangle. So, if we divide the circle into even more smaller pieces, you can see that every time the shape becomes more like a rectangle. So, how small must we divide a circle before we can get a rectangle? Well, we can keep on dividing the circle into small, smaller, or the smallest pieces we can make. But the answer is to divide the circle infinitely many times until we cannot distinguish the lines, and eventually the circle can now become a perfect rectangle.
Wow.
So, the area of the circle is equal to the area of the rectangle. It's equal to base times height. The height of the rectangle, as you can see, is the same as the radius. So height is equal to radius. To find the base, we need to look at the circumference of the circle. And when we compare the base and the circumference, we can see that the base is equal to 1/2 the circumference. Remember that the circumference is equal to 2 pi r. When we combine it with 1/2, the 2's cancel out, and the base is equal to pi r. So now, base times height becomes pi r times r. Combine the r's together, and we have pi r squared, which is equal to the area of the rectangle, which is equal to the area of the circle. So pi r squared can be used to calculate the area of any size circle that exists.
All right. So we're gonna watch that one more time so it can just really settle in. If you're at home, just scroll back.
Okay, I'm giving my classes now that we've watched that video. I want to just give an extra special warning to be careful with the difference between the circumference and the area formula. For area, as we just saw, the area formula is, A is equal to pi r squared. This is very similar to the circumference formula of 2 pi r. Those two are very closely related. Both of them have pi, both of them have r, and both of them have a 2 in it. Okay, those are the only parts. You just really need to make sure in your area formula that that 2 is written as what kind of number? As an exponent. You really have to be able to tell the difference between the two, because people will make that mistake and you misread your own handwriting all the time. So please be cautious moving forward. Okay, so we're just going to fill in the notes, which is very similar to what we just saw in the video. So a lot of times they do this with paper plates, doing that infinite cutting, but I don't want to clean up the mess of paper plates, because yesterday's yarn activity, there was yarn all over the floor at the end of the day, and doing paper plates sounds even more chaotic. And no. Okay, so you can do the same activity if you want to go home and make a rectangle out of a circle at home and just be like, ah, look what I can do. Go for it. I'm not going to be that person that you show that skill to. So just pretending a paper plate was cut into 16 pieces, arranged it as a rectangle. What expression represents the base of that parallelogram? What did they say represents the base length? They said it was half of the circumference, okay? So I'm just gonna put half of C, 1/2 of C. And then they said that the height of that parallelogram would be equivalent to the radius. Okay? So substituting that into that base times height formula, so if I started with A, the area is equal to base times height, we said that the base is equal to 1/2
of the circumference, and the height is equal to the radius. I'm going to take it one step further. Instead of writing circumference, I'm going to use the formula for circumference. So I'm going to say 1/2 of 2 pi r, that's the circumference formula, and then bring down that other r. Then with some finagling, okay, sorry for the lack of words, what's one, because this is all multiplication, literally everything's getting multiplied, it doesn't matter the order. What's 1/2 of 2? Just 1. Do I need to write a number? No. Okay, so I'm left with pi times r, and then we've learned that any number times itself is just going to be the same thing as r times r could be rewritten as r squared. Okay, so a is equal to pi r squared. That's not going to be a test question, but it's just understanding how they took that rectangular formula and they transitioned it into the circle formula. Everything is based off of that base times height. Okay? Again, if you forget that, sorry. We'll move on. All right, so let's just practice finding some areas. So again, areas talking about the space inside of a circle. So like that, yesterday's circumference is talking about the perimeter. In a lot of word problems that you're going to start seeing, sometimes I won't specify find the area of the circle, find the circumference. You will have to understand, is it talking about around the edges of the shape, or is it talking about the space inside? Sometimes I will tell you. Okay, this first one, Adrian bought an 8-foot leash for her dog. How much running room will her dog have access to? So when we're talking about running room, is that talking about just the border, or could the dog run everywhere inside? The area, it's everything running inside. Okay, also it gives us the information. One second. All right, so when it says that the 8-foot leash is for her dog, is that talking about the diameter of the circle or the radius? It's talking about the radius, because if I have a little stick here and it's going out 8, that leash is 8 feet, then I could also go 8 feet either any direction. Okay, so the radius is equal to 8 feet. Okay, we're finding the area. So as always, I'm going to start with 3 easy steps. That first step is writing the formula. So that formula is A is equal to pi r squared. Let's try that one more time. The formula is okay. A is equal to thank you. We're in there. Okay. Substitute in my values. A is equal to, it says to write my answer in terms of pi. So do I need to write 3.1426/7? No, I leave it as pi, and then r squared is going to be 8 squared. Now it's been a hot second since we've done exponents. 8 squared is the same thing as 8 times 8, so that's going to be 64 pi. Okay, again, 64 pi means I still need to multiply by 3 something. But it's going to be that. Because I'm talking about area again, my units are going to be feet or feet squared? Feet squared. Okay? Are we good with that? Copy it down. A little piece of reflection. For this formula, is there a diameter version of the area formula? Does it say A equals something with B? So how can, if I'm only given the diameter, how can I change it to the radius? Divide by 2, cut it, just making sure. Okay, go ahead, do the next 2. Do the next 3, they're all in terms of pi, ready to go. All right, sorry. Here are those answers. For number 2, you have 196 pi centimeters squared. For number 3, 10.24 pi centimeters squared. And on number 4, you gotta be careful. This gives you the diameter of 30 feet, which means that the radius is 15. Then you put that into the formula. If you got 900 pi, again, you didn't change the diameter into the radius. Okay? What's going to happen is you're going to work on the classwork. We'll check it. Oh, there's a Quizlet live. Maybe we'll get to that. That's linked, and then that homework is going to be the back pages. Honestly, for my class, I'm just going to assign half of it. I'm going to let y'all choose it. It's going to be the evens or the odds because that's a lot. Actually, no. Never mind. This is in terms of pi. Y'all can do it. Okay. And, what else do we need to work on tonight? That's for you. Thank you. Good night.